recording. Share my screen. Okay. Okay. So yeah, welcome to week 8 of Joy of Computing using Python course. And so this week we'll be uh, looking at some. So I think this week we'll be looking at some problems on tuples in Python, which is so we already have done lists and dictionaries. So this week we'll be looking at some tuples which are similar to lists, but with one key property that we'll come to later. And yeah, and then we'll also do some image processing. So I think in the lectures you were using the image library for uh, doing the image processing basically. But I'll just show you the basics of when I learned image processing. I just learned it using matrix manipulations. So images are like matrix, so we'll solve a problem based on that also, so that should be good. Okay, so let's start with something simple. And yeah, like always, if you so I'll be showing a question. I'll be waiting for 2 minutes for you to solve it. If you have the answer, if you know the answer, you can write it in the chat, or you can also unmute yourself and just say. Okay, so let's start with question 1. So this is a simple question per se. So yeah, so what is the output of this following code? So just take a look at this code and try to answer. So this should not be too difficult. Try to answer in the chat. I'll wait for 2 minutes. So we are setting a word as Facebook, and then we are iterating over the word and doing some calculations based on the ordinal of the character W. So try to find out what is going on. I'll wait for 2 minutes, then I'll solve it. So obviously you can just type it out in Python and see what the result is, but try to solve it out on your own. So any answers? Satyanarayan or Venkatesh? Any answers?
Is it the same questions repeated actually, sir, from previous to the, because they have taught the same thing, so I don't want to tell the answer in the previous class. So
Oh, I did not get your point.
no. From 6 to 7, they solve the same thing.
Oh yes. Basically, so yeah. So if you already joined the previous session, you need not join this session again. Like we'll be solving similar questions only.
Oh, it is the same, or will it be different actually?
No, for
Because
this same course, yeah. So this question is same, but because this is from one of the previous years, but some other questions I have given. But yeah. So if you know the answer, you can tell me what's the answer.
no. I want others to.
Okay, there is this Venkatesh. Okay, okay. I'll just solve it out. Let's solve it. Okay, so uh, let's just let's not code it out. Let's go one by one and see what is happening in this calculation over here. So suppose we have a letter A. Let's say, let's just start with A because it is easier. So we know that so Facebook already has an A, and so we are iterating over each character in this loop, and we are finding out the ordinal, which is like you can think of it like the ASCII character. So like if you just do ORD of say A, so that will give you 97, because 97 is the ASCII character of A. Like you can think of it as the numeric representation that the computer understands. So computer only understands zeros and ones, you may have heard that. So A just translates to the number 97. So that is its ASCII value, and it's also its ordinal value. So yeah, so this is what we are just basically storing in I here for each of the words, and then we are doing some calculations with J, and then we are converting it to the character, and basically appending it to new again. So let's see what is going on over here. So what we're doing here is basically so I plus 26 minus 97 is basically the same as we can write it I plus 26 minus 97 is 97 is basically the same as like I minus 97 plus 26. So I minus 97, what this basically is translates to is like what is the position of the character in the alphabet. So like for A, this will amount to 0. So if it is A, then A minus 97 is 0. So we have say B minus 97 equals to 1, and so on. So then we are adding 26 to it. So basically 26 characters ahead. So this is basically coming to 0 to 25. This value will come between 0 to 25. So 0 for A and 25 for Z or Z. And then we are basically just adding 26 to it. And then what we are finally doing is again we are finding out the modulus with 26, right? So what happens if we just add 0 with 26 and get the modulus? So if we add 26 and then do a modulus, and basically we get the same number, which is 0. Because yeah, like you can think of it intuitively as, so modulus basically means when you divide this whole thing by 26, what is the remainder you get? So if you have some number x, and then x modulus 26 is something, say y, so and you can, I think you can intuitively understand that if you just a second, so if you have if you are adding 26 again, so you are basically adding one whole 26. So when you take the division, the quotient will just increase by 1 basically, and the remainder will stay stay as 0. So yeah, so suppose say we have a number x by default, like or let's just call it j, because sorry, I. So that's what we have here. So what is happening here is so let's convert I to some number as 26 into x plus y. So this is the some portion. So 26 into some number, this is the greatest number that can be, and then the remainder. So this is how division works behind the scenes, right? So if you divide I by 26, this is the quotient, basically quotient, and this y is the remainder. So now when you add 26 to it, so basically when you are adding 26 to it, so this will just become x plus 1. So this whole thing is again divisible by 26, and this y is the remainder again. So basically nothing will happen, so it will just stay the same. So let's just still test it out and see if I'm wrong. Facebook new equals to empty, for w in word I equals to ord w, and then j equals to I plus 26 minus 97 mod 26 plus 97. So yeah, after those so after those calculations, finally we are again adding 97 to it, so that we can again convert the alphabetical index to the ASCII value. And yeah, so basically we are then we are converting it to a new character. So new equals to new plus character of j. This is a bad way of not bad way, but why should I write like that? You should write always plus equals to, because that is shorter. And yeah, so when we then, if we print new, let's see what print is, what new is. Oh, sorry. Let's see what new comes to. Oh, this is not what I was expecting. So it came to some random numbers. Did I type correctly? Plus 26 minus. Oh, sorry, plus 97. Where did it go? 97. Okay, so yeah, you can see that it did not change at all, because basically we are just adding 26 to it and then finding the modulus, so that just remains the same. So yeah, so this was a very simple primer into like what is ordinal and what does character do. So but this is so in this problem it was not very interesting. We did not get much interesting results, but this ORD and CHR is very useful for other operations. For example, when you were working with, say, in a previous week you were doing some substitution cipher. So when you have to do something like that, that time this ordinal and character is very important. And also when you have some other characters, suppose you want to check between some ranges, suppose you want to check if something is a space, for example, so you can obviously check for the ordinal of the space also. And I think it will come to 40, I guess, or 32. Okay, and yeah, you can check for if it's a lowercase or if it's uppercase. If it's a lowercase, then it will start from 97 and go up to 97 plus 25. And then if it's a if it's a uppercase, then it starts from 65. So if we do capital A, it starts from 65. It starts from 65, and then it goes on to 65 plus 25, which is 90. Okay, so this was a very simple problem. Let's so let's move on to tuples. So this is like a even simpler question. So this is like a MCQ. Let's not waste too much time on it. But yeah, so basically what operations can be done on tuples? So tuples basically are similar to lists in the sense that they just hold a list of numbers, an array of numbers, but there is one key difference between tuples and lists basically. So yeah, so any guesses, Vibha or Venkatesh? So yeah, basically the only difference between a tuple and a list is that tuples cannot be changed once they are declared. So tuples are like what we call as unmutable, but in simple terms that is like they cannot be edited. So out of these options, so tuples are appendable. So but that is not true because we cannot change a tuple once it's defined. And similar for delete, because we cannot delete a value from a tuple once it's defined, since it is like a constant value. But yeah, we can obviously count the number of instances of an element. We can obviously iterate over the tuple as we did with a list. So you might be thinking, then what is the use of a tuple then, instead of why can't we just use a list? Why do we need a tuple? And that's what we'll come to soon in I think in question 4 or 5. But okay, so let's move to question number 3. Okay, so yeah, try to think of the solution yourself for a couple of minutes, then I'll solve it. So write a program to create a tuple of numbers and then replace each number with a sum of its digits. So relatively simple. So if you did not have a tuple, basically the rest of it is basically the same thing. You just have to find the sum of digits of each number. But yeah, you have to do it for a tuple of numbers. So the only difference here is that you have to change the numbers in a tuple. So how do you do that? Okay, let's not waste too much time. Okay, let's just keep solving. So yeah, so write a program to create a tuple of numbers and then replace it with replace each number in a tuple with its sum of digits, something like this. Okay. Okay, so let's first write a function which actually, given a number, can calculate the sum of its digits. So it is always good. So when you have a problem which has, so you can intuitively understand what are the different parts of this, different portions of this program that you have tried. So one portion is you have to find the sum of its digits. So once you can isolate or you can bring out one part of the code, it is always advisable to write a different function for it, because then when you have to debug something, it becomes much easier. So let's just write a function sum of digits of a number. So can anyone say how to do it? Okay, there are many ways to do it, but we'll just do the most basic way, which is we'll just extract out one number. We'll extract out the number, the digit in the ones place. So we have ones place, tens place, hundredths place. So we'll extract out the number in the ones place, and then we'll divide the number by 10 to basically remove the digit in the ones place, and then we'll keep on adding it to this sum. So what we'll do is basically we'll loop over till the number reaches 0, number is greater than 0, and then if the number is greater than 0, then we want the last digit. So let's call it ones digit, and we can just get it by doing this. So if we are just doing number modulo 10, so that means what will be the remainder if we divide number by 10, and that is basically your digit in the ones place. And we add it to the sum plus equals to ones, and then to update the number, so we just have to remove the digit in the ones place. So we do that by just dividing the number by 10. But okay, let's go one by. So if we do this, there will be some errors. Can someone say what will be the error? So this looks good. Let's just try it out. Sum of digits. Print. Oh, sorry. Print sum of digits. Say 1, 2, 3. So can you tell what is wrong here? Can someone write in the chat or unmute yourself and tell me? Something is wrong in this code. Yeah, obviously we have to return the sum that is there. But okay. No chat. Okay. Let's run it and see what the answer is. So this is not our desired answer, right? So we are getting some 6.666. So what is happening here is when you divide in Python, when you divide by something, by default it amounts to a fractional value. 10 so 10 divided by 3, if you do, you'll get 3.33. So if you want the integer version, if you just want to remove the fractional part, obviously you can do two things. One thing is you can do you just can convert it to an integer, that will give you 3, or you can just do double slash. So this means that divide and only keep the integer part. So I don't know if this will work. Let's see. I never tried it. Yes, it works. So this basically means you divide it and keep, like, do an integer division. So you remove the fractional parts. Okay, so now we have the basic sum of digits function. So now we want to just replace each number in a tuple with its sum of digits. So yeah, so the problem, so with a list, so suppose we have a list, say L equals to say some numbers, say 1 2 3 4 5 6 7 8 9. Suppose we have a list like this. So what we can do basically to update the number is basically we can iterate over this list. So let's say for I comma n in enumerate L. So we are just enumerating, we are going through the list one by one with the indices and the numbers, and then what we are doing is list I equals to sum of digits n, and then if we print L, what we will get is what we would expect. So 1 plus 2 plus 3 is 6, 4 plus 5 plus 6 is 15, 7 plus 8 is also 15, and 9 is just 9. So we are getting the correct result. But what if we do it with a tuple? So okay, so to declare a tuple, I hope you have watched the lectures. So to declare a tuple, we just change the third brackets to first brackets or parentheses, and yeah, we get this error that is the property. So tuple object does not support item assignment. That is the problem. So what we can do here is basically, since we cannot change, we have to make a new tuple out of it basically. So what we have to do is basically we have to create a new list. Say let's call it new list, and we can just append new L dot append this, and finally we have to convert say it to a tuple. So tuple new L. So what this will do is it will convert this list into a tuple, and if we run it, we'll get the same answer but in a tuple format. You can see that earlier there were third brackets and now there are parentheses. Okay, so you still might be wondering why do we need to do this if they are more restrictive. So we'll come to that soon. But okay, so any doubts about this? So this should be very straightforward, basic stuff. But any questions if you have, can ask me. Unmute yourself and ask me. Okay. Okay, let's see. We have one more pointer about so one thing, yes, this is something. Yes, someone has a question, or I have a trivia question for you. So I'm not sure if it was taught in the lectures, but so you can define a tuple, say 1 2 3, right? So but how do you define a tuple with only one element? So you can define a list like this, but if you do just this, so it just comes out 1, because it's just a number with parentheses. So how do you define a tuple with just one element? Can anyone tell? Don't search Google, just tell me if you know. How do you define a tuple with only one element? Okay, so the answer is slightly counterintuitive, but yeah, so you just have to give a comma after it, and that's it. So if you give one number or anything like one element and you follow it with a comma, then it automatically becomes, so this is a tuple with only one element. And if you do 1 comma 2, then it becomes a tuple with two elements. What happens if we do this? It will still become a tuple with two elements, right? So this is, sometimes it is useful when you want to create a tuple of only one element. Okay, so let's move on to slightly more challenging questions. Okay, so this is also just using the tuples as like a data structure. So this program is something that you have already done, but with lists perhaps you have already done. So write a program to create vectors as tuples of numbers. So you suppose you have two vectors which is represented by tuples, and then you can write two functions for finding the sum of the vectors and finding the dot product of the vectors. So since we don't have too much time, let's just solve it. So let's call it, say, add vectors and dot product of vectors, right? So suppose we have two, let's define two vectors v1 and v2. Let's have some numbers, say 1 2 3 4, and v2 is say 5 6 7 8. Simple as that. So now you want to just add them. So you know that vector addition is just adding the individual elements you have to add. So you have to add 1 plus 5, you have to add 2 plus 6, you have to add 3 plus 7, you have to add 4 plus 8, and you have to create a new vector with those numbers. And if you have mismatch in the number of elements, so you cannot add those two vectors. And similar with dot product, they must be of the same length, and to find the dot product you have to just do, say, 1 into 5 plus 2 into 6 plus 3 into 7 plus 4 into 8. So this is how to find the dot product. So yeah, obviously dot product is a scalar quantity, whereas if you add two vectors it will be a vector itself. So this is the dot product. I hope you can understand. 1 into 5 plus 2 into 6 plus 3 into 7 plus 4 into 8. Okay, so let's write two functions, one for adding two vectors and one for the dot product. Define add v, let's call it add v. So v1 v2. So here also what we can do is always we should check if these are of the same length. So what we can do for checking is, obviously we can do a if statement. If v1 not equals to len v2, then say print size mismatch or something, and then you can return. Okay, but and then you do the, if they are same, then you do the other stuff. So we are coming to that. But another way of doing this is so this when you write such checks, so these are like, you can call them sanity checks, or like checking if the input is valid. So when you are checking for format is correct, so if you just write if statements, then it can often get lost in the code. So if you have many if statements one after another, so you can forget which part is just checking the input format, which part is doing the actual work. So a better way to do it is you can do an assert. So what assert does is, assert, you give it a condition same as before, assert equals to len v2. So what this does is it just checks this, and if it is true, then it will just do nothing, it will just carry on. And if it is false, if the lengths are not the same, then it will throw an error. So I'll show you what I mean. So let's just, for now, let's just call it print something. So let's call add v. So if we call add v with, say, okay, let's just call it here add v with v1 and v2, we can just see that it prints that dot dot that I printed. So nothing happened. But if they are not the same lengths, so this assert will get triggered and it will throw an error, assertion error, right? And also you can give some custom statements. So I think do it with a comma or with a colon, I forgot. Most probably with a comma. So you can give a statement length or size mismatch, like we did before, size mismatch. So now let's run it. Yeah, so now it's showing assertion error, size mismatch. Okay, so this is a good way to actually, when you have to check your input, or have to do some checks that are not part of your main code, then it's often a better thing to use assert. Okay, so that was a slight deviation, but okay, let's get back to the problem now. Okay, so now that we have asserted that the sizes are same, so what we can do is we can iterate over these two vectors one by one. So and we can, let's call it say x, or element 1 and element 2 in zip v1 v2. So what zip does is basically, if you just do for for example uh, for e1 in v1, so you know what this will do. This will just iterate over each element in v1, and e1 will contain one element of v1. So what this zip function does is it does the same thing but with two lists simultaneously. So it will iterate over these two lists simultaneously, and so e1 and e2 will be first, they will be 1 and 5, then they will become 2 and 6, and so on. So this will make our work a lot more easier. And so to add, we need to, so like the previous problem, we cannot really modify tuples, so we'll just create a new list, and then we'll before returning we'll convert it to a tuple, and then yeah, let's see. So result equals to say a new list, and then result will be result dot append. So what do we append? We just append e1 plus e2, simple as that. So vector sum is just sum of the individual elements, and then we return a tuple of res. Right. So let's see if we got the correct answer. Print this. So yes, so this is straightforward. Hopefully the results are correct. Yes. Okay. So this is straightforward. Also, let's do the dot product. That is also let's call it dot pv for vector v1 and v2. So again, we can have the same check because the lengths need to be the same. And here also we just need to just do very small changes. Let's just copy paste. Okay, let's write it. Why not? So we are here. We need to calculate the sum, right? So we need to multiply individual elements, and we need to then sum it up. So let's call the s equals to 0 for e1, e2 in zip v1, v2. So now we have to do the sum. And what do we add? We add the product of the elements. So e1 into e2, right? And then we just return s. Print dot pv 1 v2. So if we run it, it should give us 70, and hopefully that's the correct answer. You can calculate and check. But yeah, so this is how you can using tuples, you can like treating tuples as vectors. Okay. And okay, let's move on to the next question. But before that, any questions? Do you have any questions? Let me check the chat once. Okay, no questions till now. Okay, then yeah, so let's solve this problem now. So suppose we want to store the marks of a student in a particular subject in a dictionary. So you have already worked with dictionaries, right? So but the key is, like, we have two keys. So one of the keys is the roll number of the student, and one of the keys is the course number. So we have two things as key. Okay, so we can have the same student with the same roll number in multiple courses, where and also like the same course will have obviously multiple students. So we have two things as key, and we want to store the marks as the value of the dictionary, right? So this is a, so how do we do it? So let's just think. So let's forget we are working with tuples. Let's just try to do it other ways. So let's just create a dictionary with yeah. So this is not really a program, this is just initialization. But yeah, so what do we do is, let's try to do it with define a dictionary, say marks, and so we can obviously make a menu driven program with input and stuff, but let's just do the initialization here. So suppose we are declaring this marks dictionary. So the key will be student and the roll number, right? Sorry, the roll number and the course number, right? So say So this was my roll number during my masters. Yeah, and say the course number. So I think this course is CS 122 or something. And then we can have a key, right? So let's say, so I am the teacher, so I got 100. Okay. And then we can have, say, someone else in the same course. Okay, let me just do it line by line. In the same course, someone got, say, maybe not so good, and yeah, not so good in like Asian terms, because 90 is not so good, but okay. And maybe I took another course, maybe CS 38, and maybe I got 95 here, and yeah, this other person also did this course and they got maybe say 99. Okay, so this is how we can uh, declare a dictionary with multiple keys, right? But if we try to run it, it will show you some error that it is an unhashable type. List is an unhashable type. So this is exactly when you need tuples, uh, because tuples are basically like lists, but you cannot change them. So not going into the details, but you can think of it like when you are using a tuple, then Python knows that this is not going to change, so it makes a fixed representation in the memory, so it can so you can use it like a normal integer or something. So if we just convert these to tuples, so now we can see that there are no errors and we see marks. So we can see that we have this dictionary. So now if you want to say search for marks in a student, so suppose if you have to write a code for searching the marks of a student in a particular course, then obviously you can just do marks something like this. So you can just access it normally like this, as you would do with say a normal integer or a string, and it will show you 100 the value. And you can also write programs with this. So when like if you have to search all keys in with this course numbers, if suppose you want to find all the marks in this course, so you can do that also. So you have to get all the keys from, so I hope you know how to get all the keys, right? So you can do this to get all the keys. So here you have to get the keys, and then you have to match which of the courses match, and then you can sum them up and like find the average and stuff of the marks for that particular course. But yeah, so this is just how you can use tuples as dictionary dictionary keys. And also for values, actually you can use lists or tuples, anything. So values don't really matter, but the keys, if you have to use more than one value, then you have to use tuple for that. Okay, any doubts so far? Okay, hopefully not. Turn this on. Yeah. Okay. So let's move on to the next question. So I think this week you, like week 8, you did some image processing using, so I think the basic Python image library, PIL, Python image library, and also I think CV2. But so I think there were some, so I did not go through in details, but I think there were some examples to flip a image or crop a image or something. But what we want to do is basically in this problem, what we want to do is like we don't want to use built-in functions. Let's go a bit deeper, because it's honestly it's not that hard. So if you know matrices, basic matrix operations, then an image is basically a matrix, right? So basically, if you consider a grayscale image which you you may know as a black and white image. So something like let's actually download an image and try it. Let's say some image said doggy. Let's just download an image with less borders. Suppose let's just download this. Okay, forgot where I have to save it. I guess here. Why is it WebP? Okay, hopefully should not be a problem. Okay, so if you have a grayscale image, grayscale image. So a grayscale image is something like this basically. So what we usually refer to as black and white, so that is a grayscale image. So you have only no colors basically, whereas black and white actually refers to just binary, just black or white. But yeah, these images are called basically grayscale images. So if you have a grayscale image, then you can think of it as like a so let's actually try it out. Save this. Let's save this image also. Let's call it gray.png. Okay, so we'll see what all of these numbers are, but basically you can think of this image as pixels. So you know pixels, right? So we already have these screens 1080 resolution. So there are 1080 pixels across, and yeah, so each pixel represents some color, or in this case, like if it is like the how much gray is there, how much white is there, or how much black is there, right? So each pixel represents one point in space that represents a value which corresponds to the color, right? And if you have colors, if you have a color image, then we just have three matrices you can think. So each pixel is basically three numbers, the red, green, and blue value. I hope this was covered in the lectures, but okay, I'll just write it down again. So gray images basically means matrix of pixels, and each pixel is basically an integer between 0 and 255. So it's between 0 and 255 because so you don't need to remember this, but it's between 0 and 255 because in computer memory it is stored in like 1 byte, so like 8 bits, and you can store maximum 256 numbers in a byte. But yeah, that's not required. But so yeah, so we have 0 to 255, and here what these numbers represent is how much gray it is. So 0 represents completely black, and 255 represents completely white, and anything in between is some form of gray. Okay, so let's use the image library. We'll just use it to import the image. I need to check the file name. Okay, file name was okay. Let's call it doggy. I hope it will load. Let's load the gray image first. So img. So I hope this much you have remember. Dot open gray.png. So is it working? Yes, it works. Okay, good. So we have loaded the image. So now we can obviously do image.show. It opened up. So yeah, you can see the image. This is the image that we downloaded. So now if you want to convert it to a matrix, then we have to do slightly more tricky stuff. So you might think it's not worth it because we have to do additional stuff, but the point of this question is to see what goes on behind these image processing algorithms, and at the end of the day, image processing algorithms are just like matrix calculations. They just work with matrices, and if you can work with a matrix, then you can work with images basically. So we'll just import numpy as to load the numbers. So numpy will not do delve too much into numpy, but you can think of numpy as a like mathematical library which does mathematical computations very well. uh, and we'll just use a vector over here. Like a vector is like a list. So let's convert our image to a matrix, and to convert it you have to write it as array img dot convert sorry oh convert and you have to give L. So what L means is, so you can already see the description in the site. So L basically means grayscale, and then RGB means like red, green, blue, 3 colors, and CMYK is another format of colors, like the ones that printers use, like cyan, maroon, yellow, black. But yeah, for this, since this is a gray image, we'll just do this, and no need to show the image. So what we want to do is we want to see what is inside this matrix. So we got a matrix, so let's explore this matrix a bit and see what is there inside. So if we just print the matrix, we can see that this is a 2D array obviously of some numbers, and you can see some numbers in between, right? So these are the individual pixels. Okay, so we can check the size. So size, oh sorry, not size, I think shape. Okay, shape. So this image is 338 cross 600 pixels, right? So we can even check over here. So if we go into the properties of this image, you can see that I am not sure if you can see, but it is 338 pixels height and width is 600 pixels, and that is exactly what we see here. So height is 338 rows and 600 is the width. So each point or each element represents a pixel value, and so 16 means darker, and like as close to 255 it is, that is more whiter. So let's look at the image side by side once again. Yeah, so you can see the middle values are closed off, but you can see that these corners are quite black, and they are like very low value. So 16 is low value, and then these high values, there are 235. These are high values, so they appear as white. So let's do some basic modifications. So let's just say we want to convert all pixels greater than say 200 to black color. Okay, so we want to convert all highly white pixels to black color. Let's say we want to do that. So what we can do is for NumPy, it is the same, similar to using Python lists, but better and easier. So you know that we can do indexing. So in Python lists, we have to do indexing like this in a matrix if you want to do all of the elements. But in NumPy arrays, we can just do comma. So this means all the rows and all the columns basically, and we want to assign rather than 25. So let's see 200, right? So what do we get when we run this line? So when we run this line, we get this kind of a true false matrix, which tells you which numbers are basically greater than 200, right? We can just do mat greater than 200, I guess. Yeah. So what we want to do to change so we have to change matrix this equals to 0. So it is that simple. So this is basically the beauty of NumPy. I'm not sure if you had NumPy in one of the lectures, but so we'll not go into too much details here. But yeah, you can obviously convert a NumPy to a normal list also. So if you have mat dot to list, if you do, then you'll get it's a big number. It's a big list. So you can see we get this as a normal Python list. Okay. So if you are not familiar with NumPy, you can just do dot to list and get the matrix and work on it yourself. But using NumPy, we can obviously do it much quicker like this. Okay, let's move a bit quicker. I think we should finish in 10 minutes. Okay. So now that we did this, now if we check mat, now we can see that these bigger values that were greater than 200, like these values were 235, they have become 0, right? So if you look at the image, image, where is the image? Okay, so these values have been turn to 0. So let's show this new image. So let's convert it to a new image. Let's call it new image, or say an image equals to, and this is also slightly tricky. So image dot, I think, from array, and you can do matrix, and then you can do an image dot show. So let's see this new image. Did it come? Yeah. So this is the new image basically. So you can see that these values that were greater than 200, these have been converted to pure black. 0 is pure black. So you can see these are still a little bit less black, these are more black. Okay, so this is how you basically work with images as matrices. So now let's so what did we have? So if you want to crop, so now that you have converted your image to a matrix, so you can crop it out very easily. So suppose you want to let's load the dog epic. Okay, let's work with this only for now. So if you want to crop it out, instead of doing that, you can just do something like mat equals to matrix of, say you want to reduce 50 pixels from each border side, right? So you can do something like this. So you start from the 50th pixel and you end at like minus 50 pixels. You end this 50th last pixel, and then you can do the same for like basically the rows and the columns, right? So if you do this basically just crops the image. Let's see. So you can see that the image has been cropped if you compare it with the original image. So this is the original image, and you can see that it has been cropped. Okay. So you can see the cropping is just like you're taking a slice of the matrix, right? So that is cropping an image. If you want to flip the image, suppose you want to flip the image. Yeah, so flipping on left to right or right to left. So that also we can do. Let's just remove the cropping and let's just do. So to flip, you can do something like this. So this is similar to what you would do in a normal Python list. So to reverse a normal Python list, this is what we would do. So start from the beginning, or like basically start from the end, go till the beginning in steps of -1. So this means basically you reverse the list, right? So if you show this, you can see that. Okay. So this is the original image on the left and the image on the right. Oh, it did not. Why did it not? Oh, it did, but it. So I did it both ways, I guess. So let's just do. So do this. This means that it will just flip on one axis. So I flipped it on 2 axis, and if you flip it on 2 axis, this image basically becomes the same. Sorry about that. So if you just flip it on, say, the height axis, so what do we get? So now you can see that it has been flipped, right? So this image is not very good to visualize the flipping. So let's load the dog image, and I think that will be better. So what the dog image is, good and bad thing about it is that it's a color image. So there are 3 channels actually. So a grayscale picture is just each pixel will be a number, integer. So for color image of pixels, so each pixel will not be just one integer, but each pixel will be a tuple of 3 numbers, or you can think of like a list of 3 numbers basically. So each pixel is a, or you can say, array of 3 numbers, and these 3 numbers are actually its red, green and blue values, and each of these can be from 0 to 255. Okay, so if you have, say, 0 red, then like there will be no red, only green and blue. If you have, say, something like, so you have seen some numbers. So if you have worked with paint, you have seen these numbers maybe. So if you have something like, say, red is 0, red is, say, 0, blue is 255, and then green is 255. So this means that you have 0 red, and blue and green is there fully. So blue and green, if you mix blue and green, you will get yellow. So this basically means yellow color. And if you want say magenta, then I think this will be magenta. So if you have 0 green and full red and blue, right, so you will have magenta. And obviously you can choose any combinations of these to get different colors. Okay, so this is basically how image is represented as matrix, like a color image. So let's see if you can load this dog image. WebP, I'm not sure. And here we have to do RGB. Let's see, did it work? Yeah, so you can see we flipped the image already. So let's look at the original image also. Okay, so the original image is like this, and this is our generated image. So you can see here more clearly that we flipped on the, like, the height, the rows we have flipped. Okay, and we can similarly we can crop as before, obviously. So if we do something like 50 to 50, and so all of the width, let's keep the width the same. Oh, what happened? Oh, sorry, minus 50. Okay, so now we can see that this image has been cropped, you can see. Okay, so any questions so far? Otherwise we'll quickly do a border and then we can end the class. So I see no chat messages, but if you have any questions you can unmute yourself and talk. So let's quickly finish this. So suppose, so now we have this dog. So suppose we want to add a border to, suppose we have cropped this image and we want to add a border, say a white border. So we have already seen the image. So suppose we want to add a 50 pixel wide border across, like a frame, right, of maybe, say, let's say white, yeah. So let's just say this. Okay, so what we have to do here is basically we have to create a new matrix, and yeah, and then basically copy paste this inside the relevant portion, right? Okay, so one thing we did not see is, yeah, so for this we loaded this image, but we did not see what is each pixel. So now you can see that it comes up as a, so each pixel is a 3 digit, you can see. So this is basically 1 pixel. So if you do something like matrix 0, 0, so this is the first pixel. So you can see the first pixel is this color, right? So red, green and blue. So you can also do some color changes. Suppose you want to do turn off the red color, you want to make the dog or maybe you want to make it greener and bluer. So suppose you want to turn off the green colors from it. So what we can do is we can do something like this. So again, now this is like a 3-dimensional matrix. So similar thing as before. So all rows, all columns, and then we select the green pixel. So the green pixel is like the second one. So red, green, blue. So red is 0, green is 1, blue is 2, and we set it to 0, right? So now if we look at the image, we can see that it has become reddish because we have removed all the green from the image, right? So you can do the same thing with, say, other colors. Suppose you want to remove all of the red. So this is removing all the red. So now let's see. So you can see it has become greenish and bluish, right? Let's just also try with blue. Suppose you want to remove all the blue, and then you can see it has become yellowish because all of the blue has been removed, right? Okay, so this is how a 3D, a color image is represented as a 3D matrix. Okay, so let's go back to our border problem. So this is our image. We don't need this. Let's comment it out for now. So let's create a new matrix, new mat. Okay, and let's do it np dot. So NP has some built-in functions like this np.ones, basically, which means just create a matrix with all ones, right? And you have to specify the dimensions. So the dimension should be the same as the already existing matrix. Let's do this. So what this will do is, let's see what this does. So if we do this, new mat dot shape. So this is basically a new matrix with the same dimensions as the original image, but all of the values are basically 1. So new mat, all of the basic values are basically 1. Let's convert it to d type equals to int. Okay. So this is basically, we are just converting it to int, nothing fancy. Okay. And we want to fill up the borders with white color, right? So we'll do into 255, right? So if we do all 255, so if we do red equals to 255, green equals to 255, and blue equals to 255, so then it becomes basically white. And if you do all zeros, so red 0, blue 0, green 0, then it becomes black basically. So if you want white, then we want all the numbers as 255. So that's what you have done. So now if we take a look at the matrix, you can new mat. So you can see new matrix, all of the numbers are 255. And if we just print out, if we just run this code, and if we just see what new mat is, cannot handle this data. Oh, okay. This should be, I think, uint 8. Okay. Okay. So this is just basically a way of saying that 8 characters, since this is an image. So you can see this is a plain white image, right? And if we did 0, if we do multiply it by 0, and if we run it, if we run it now, then we can see it's a completely black image, right? So now that we have this part, so now that we have a white image, so what we'll do is we'll just copy this portion of the dog image into this new matrix, right? And in NumPy it is again very easy. You can do you can just say from which position to which position. You can directly just say 50 minus 50 and all of the pixels equals to this basically, or you can just do this. I think this should be good enough. So what we are doing is we are telling that in the new matrix, in these locations you copy from this previous matrix, right? So I think you can understand this. So we are taking the chunk of, we are taking this chunk from the original image and we are placing it inside this new matrix, the blank white image, right? Now if we run it, let's see what we got. So we got a dog with a white border. Yay. Okay, so I think that's it for today. So any questions you have about this image processing or anything? So the objective of this, so obviously if you follow the lectures, you can see that they have used some functions in the image processing library, right? So the point of this problem was to show you that so image processing is nothing, it is just basically matrix manipulation, and you can actually do it like this. So once you convert it to a matrix, it is very easy to work with. If you don't know NumPy also, you can convert this NumPy to a list also. You can convert this to a list, and you can do normally how you would write a program for a list, like a matrix with a list. Okay. So any questions?
Sir, as part of the lecture, they have used CV2, I think. So
Yes.
where should I see whatever you are showing this screen,
Yes.
where I have to load that CV2? Because it is not, it's saying package could not be found.
Yes, so that's why I have not used CV2. So CV2 is a much more powerful image processing library, but CV2 is not built in with Python. CV2 is a separate library. You have to download and install it. So I think if you Google it, you will find like install CV2 Python. So CV2 is available for Python and C++. So you can, if you know how to use pip or conda, you can use like pip install OpenCV Python. So if you do this, so in the terminal you have to write pip install this, then it will install and then you can import. So it is not used by default. Yeah, so by default this PIL is there, Python imaging library, this is there, but this is very basic. It can only perform very basic operations like flipping images and yeah, I think cropping, loading, and showing them. But yeah, if you want to use CV2, then you have to install it. So you can just Google how to install CV2 Python, and then you will get some uh, results. So I have not used CV2 here because of the same reason, because I don't have it installed, or maybe I do. I'm not sure. It's been a long time since I've used it, so yeah, it's not there. Yeah.
Okay, okay. So it cannot be done using the Anaconda itself
No, you have to install it.
to take.
You can just do
Oh, okay.
something like pip install. I guess. How do you pip install? I think you have to do open CV Python, and then it will install it. So right now it is installing, but I don't want to install it. But okay, so it is like very that easy to install it. So you just open a Python terminal, and then okay, done. So now you can import CV2. So it's imported, right? So it's that easy. Okay, so just do pip install OpenCV Python, or you can just Google. So if you Google, you will find this page or some other page, and then you can see how to install it. Okay.
Okay, okay.
Yes. Any other questions? Otherwise, we can end the class. I'll stop sharing my screen. I'll stop the recording.